All right, well, welcome right back to track one on day two of the Python Lab Conference. I have got Mike Moran joining me today, who's talking about AI content predictions for large websites. Due to the late start, he will answer questions in the gallery section afterwards. So I'll let Mike take it away.
Thank you, Calvin, and apologies everyone for the delay. Had a bit of technical problems, but here we are. So let me talk to you about content prediction for large websites. So let me start with a question for you. So what if I had you think about a company that has a terrific customer experience? The website is fabulous. Is this the one you thought of? For most people, it probably is, and even if it wasn't, well, I got to tell you that that's probably a website that nobody said to themselves, oh, those guys, they're terrible. I hate their site, right? So all of us would like to have a website like Amazon, and what's really their secret? Well, there's two things, really. And they're both about content prediction. It's about site search, because when's the last time you visited Amazon and did not search for something? And it's about related products. So telling you which other products people might have viewed. Both of those things are content prediction, and that's what we're going to be talking about. So what happens if you have that great customer experience because your content prediction is working? Well, you get higher sales, higher profit, and you end up with higher growth. What it really does is it increases your marketing yield. So the people who come to your website actually buy from you, whether they're buying online or whether they're filling out a contact form to buy later. So the challenge for websites is that they all want to be like Amazon, but hardly any of them succeed in doing that. And so why is it so hard? Well, if you try to do it the way Amazon does, you need a lot of personal information. You also have the vast majority of your visitors don't have personal information for it, so most websites don't have that, and this is the reason why. What's starting to happen is that the world has changed. And if you look at this graph at the top, this shows all of the incidents of breaches for over 100 million accounts. There's a lot of them. And remember, it's only over 100 million ones. And then you can see how they've started to speed up over the last few years. Well, this is the response to the industry. They're tracking cookies differently. GDPR and CPA have come in, and third-party cookies are now going away. And so it's getting much harder for companies to get this type of information. And how do we know? Well, we actually talked to 147 senior marketing leaders for large companies, and what they told us was that they can't do personalization, they can't do content prediction, they can't fix their site search because all the software out there is very expensive, there's way too much content required, and they have their IT team has to jump in and fix things at every step of the way. And so this is what makes customer experience so difficult for big sites, is they have anonymous visitors and they have massive amounts of content. If we talk about large websites, even a small large website has tens of thousands of visitors. Some of them have millions of pages. And so let's think about what you have to work with here. You've got anonymous visitors, massive content, so what kind of things can you apply? So you still have the ability to collect data on your visitors, and you can understand what your content is about. And there's AI that can help you with both of these things, and that's what we're going to talk about in the rest of the presentation. So relevance is really at the intersection between people and content, and that's really what a content prediction engine does. It figures out how you are able to know which content is the right content to come next, right? So whether it's because someone searched for something, so they went into site search and they're asking for something, or whether they're just navigating through the site, you are trying to predict what content is happening next. And so what kind of data do you have to work with to focus on this? Well, you can look at what pages people visit, you can look at what keywords they search, and you can look at the forms they submitted. And what do those things tell you? Well, the pages they visit tell you what kind of content they're interested in. The keywords they search tell you what their intent is. And the forms submitted are what tell you when they succeeded. Because if they filled out the form, it's likely that they found what they were looking for. Now, what kind of data do you have to work with on the content side? Well, you have the structure of the site. You know which pages are linked to which other pages. You also know the content topics, so you can figure out what the content's about, and you can know when content is related to each other by topic. And you also have content journeys. You know what the path is that the information architect designed to bring you through the site to actually succeed. And so both of these things are really the fodder, the grist for your mill. And so let's look at AI using behavioral data. So how do we collect behavioral data? Well, first you put a JavaScript on every page of the site. I know this is a Python conference, but you can get over it. So the JavaScript collector can look at things like all of the clicks, all the mouse movements, the timings, like how long they spent on the page, did they scroll down, and then we have built a Python aggregator, and what it does is it actually looks at this as an experience. So it's not just collecting the data discretely. What it's doing is it is analyzing pages, putting them into sessions, making sure that we're tying user activity together. And so all of those things are things that can be done, and we're storing it, in our case, in a Postgres database, but we're anonymizing all the data. So we do pull some PII, but only the IP address. And what we do with the IP address is we do a one-way hash so that we can still know that when that IP address comes back for another visit that it's the same person, but there is no way to ever reverse engineer our identifier back into their IP address. And so what that allows us to do is to know that we have the same person, but we don't have any PII, and so we're not subject to GDPR or CCPA or any of those alphabet soup type of privacy regulations that are emerging. We don't have any information that can be tied to a person, even though we know that the things they're doing are the same person. And so what do we start with? Let's start with site search data. So the first question to ask yourself is, are site searchers finding what they're looking for? And what we try to do is identify when we have found failures. Now, why are we doing that? Well, because if site search keywords tell us what the intent is, if we can find out when people succeed at finding what they're looking for, then we've made a connection that says we know which content is tied to which keyword. And so we know what kind of intent actually delivers on the content. And so first we look at things that tell us that we have a miss, that we have a failure. So if you search for something and get no results, well, that seems like a failure. If you search for something and get a screen full of results but nobody clicks, well, that seems like a failure too. And so the question is, well, suppose you get results and they click. Does that mean it's a success? Well, not really. We all know that you click on stuff all the time and you actually don't find what they're looking for. So we call those, very cleverly, failed clicks. And so they got results, they clicked on something, but there's behavior that they exhibit that lets us know that, hey, I think they were failing. And so let's look at some of those behaviors. So they might do something called a pogo stick. So they might click on a result, go to the page, but then click back to go to the search results. So you might ask yourself, is that a failure? Is a pogo stick a failed click? And somebody might say yes, because if they found the right information, why would they go back to the results page? Other people would say, well, no. Maybe the searcher is looking at some type of deep topic and needs to review several pages. So maybe that was a success. What's another thing you could look at? Well, you could look at exits. So you say, hey, if they go to the page and then they exit the site, they don't do anything else, well, that's a failure, right? Because if that was the right page, why would they leave? And someone else say, well, maybe they found their answer, and so they're done with their visit and they're gone. And so, again, you have this ambiguity. And one of the things that AI is really good at is resolving those types of ambiguities. So look at another example. Suppose they did a new search. So they did a search, got results, clicked on a page, and then they go up to the search bar at the top of that page and they enter another search. Well, you might say, yeah, that's a failure, because if they found the right page, why would they have to enter a new keyword? Or you could say, well, no, that's not a failure, because maybe they found the answer to that and now they have a new question. So one of the things that you can do is you can look at patterns in the search keywords, and if you start to see unusual patterns, those are things that are likely people that have a new question. But if you start to see patterns that come up over and over again, it's likely somebody's refining what they're doing and they really didn't find the answer the first time. And so these experiences aren't black and white. Maybe they're failures, maybe they're not. And so the question is, how do you tell the difference? So what we do is we look for success signals and failure signals. So success signals might be that they completed a task, or they clicked on a content link, a link that's in the meat of the page, or they spent a lot of time on the page, or they scrolled way down on the page. And failure signals are the opposite. They didn't do anything, and maybe just exited. They clicked on the site navigation, including a new search, or they spent a short time on the page, or they never scrolled. And so a lot of it has to do with engagement. How long were they on the page? What were they doing? Did they scroll down? And what did they do after that? And so it's not true that any of these things are rules. You can't put together rules that say, hey, if they did this, then it's a failure. If they did this, then it's a success. What you start to do is you look at these signals and you start to help understand that what you're really trying to do is to have weights. So first you start out with arbitrary weights, but then we start to use AI to be able to tie what we know to be successes, because, for example, someone completed a task, and we look at all of the behaviors before they completed the task, and we start to use our data science team to tell us which other things are correlated with completing a task. Because even if you find something, you might not necessarily complete the task. You might have found your answer about the product, but you don't like the product. And so it's not the search that was bad, it's the product that was bad. But looking at all of the data helps us find the patterns of what things seem to lead to successful outcomes. So now we're starting to understand which keywords people are successful with on what pages. So we now have an idea of which content actually answers a certain intent. So as we look at the task completions, what we might see is that they did another search, but they shifted their intent. So they're actually trying to do two things in the same visit. And so this is something that we can start to detect using the data science and the AI. And so as we start to understand how to reveal that intent, one of the things happens is that we can start to use the data that we picked up from site search and now start to apply it when people are navigating. So look at these two examples. If you, for example, in the first one, did a site search and landed on a page, and let's say you were successful. Then you did another site search and landed on a page, and let's say you were successful again. We now know what the intent is behind those successes. Well, if someone else comes along and they land on that same page, maybe they got there from Google, we can kind of guess what their intent was if they're showing success signals. So if they're showing, hey, this is a page that's really interesting, I'm scrolling down, I'm clicking on something else to move forward, that tells us that what their intent was. So now we're using what the page was to back propagate what the intent is. And so by using these types of techniques, we start to understand what pages are good at, and so then we can guess at what people's intent are. And especially when they start looking at patterns of 2, 3, 4 pages in a visit, and we know what the intents are for each one, we can be very clear if they seem to be showing success signals all along the way, that this is the intent that they have, and now we can kind of guess at what task they're trying to do and can try and help them get there. So how do we really do that? Well, we use these types of predictive analytics and AI techniques by looking at the data in our database. We can then bring it through a GraphQL API, and this API is actually available to the developers of all of our clients. And we're using scikit-learn and Spacey NLP for our AI. So I have a long history in AI. I've actually been working in AI since the 80s, and we've used all sorts of different packages. Because we're a Python shop, we have looked at a lot of different machine learning packages, and what we found is for our data, they all work relatively the same. So we've looked at all sorts of things out there, and scikit-learn, even though it's been around for a while, it has the ability to look at all sorts of different algorithms very quickly, and so for our data science team, we can test things really, really easily. Spacey is the best NLP package out there for Python right now. There's some controversy around Spacey because people didn't like Spacey 2.0 because it was much slower than 1.0, but because we do all of our analysis in batch, it's not really a big issue for us. And as we see more natural language and national languages coming on board, we think we're going to stick with that for the long run. So what is in that GraphQL API? Well, you can get a hold of any of the site searches that people had and what pages it left to, and whether that was a success or not. The facets they used, whether that search got a result or a click. You can also look at the results themselves. So look at page by page, what keywords led to them. Again, the facets. You can look and see what the URL was of that page, what the ranking was on the page. So was it the first result, second, third? For page navigation, you can also look at session IDs so that you can link all the page navigation together into sessions, what URLs were viewed, all the events on the pages, time on page, and channel type. So did it come from your Facebook ad? Did it come from an email campaign? Did it come from Google in paid search or in organic search? So any of those things are things that you can pick up from the API. And internally, we've implemented a number of things that take content prediction into account using all of the data in that API. So here's an example of auto-suggestion in site search. So you've all seen these before. You start typing a word and it tries to auto-complete it for you. And the way these systems usually work is they complete based on what is the most common term searched based on what was typed in, or some term that was in the search index. Well, we use those types of techniques too, but we actually flavor it with which search terms are the most successful, because we can actually get people to the right answer faster. And so that's actually one way that we can actually pick up a couple of points of search success without the company needing to do anything about their content. Here's another way that we use it. And this is actually something that, and both of these things are things you can implement yourself with your own search engine in using that GraphQL API. We actually not only provide the GraphQL API, if people want it, we have an Elasticsearch implementation where this is already integrated. And what it does is it auto-curates. So many of you are probably familiar with manual curation. So if you aren't getting the right result for a particular keyword, you can go to the search engine and say, pin this page to the top, make this number one. So even though the search engine is bringing back the wrong page, we're going to tell it the right page. And so what we do is we actually look at the success data to gradually move the right pages up the list. So we can store the success data in your search engine search index and help you with your relevance ranking algorithm, so it starts to use previous successes as part of how it ranks things. And so there's a lot of different techniques that we can help with to improve site search. We've had clients that have gone from 23% success to 53% in about a year, because there's all sorts of things you can do to make things better. And this is actually how you start to deliver that customer experience that Amazon has. So that was a quick run through how we use the behavioral data. What I want to do now is to talk about how we actually look at content, and especially how we determine topics for websites. So if you start with pages on the client's website, then you can use either a sitemap crawl or a discovery crawl to go through and pick up all the pages. We tend to use Headless Chrome as our crawler because we want to be able to pull in all sorts of data that you wouldn't get from kind of a typical text-only crawler like Scrapy, which is what we used to use. And it's a perfectly good crawler. It's just that we have more information that we're trying to pull back on the page. And again, same suspects of scikit-learn and Spacey. But this time what we're doing is we're dumping it not into Postgres, but into Elasticsearch. This, first of all, provides a search engine that allows the customer to use this search engine on their website. But the other thing it does is it allows us to have very quick retrieval, and we'll show you what we use that for. We can actually do content recommendation when people are navigating on pages. So you saw how we can do content recommendation when people are searching, right? They either get a better suggestion on the screen, or they get a better result on the search results page. This can help us to focus on how we show people better content when they're just paging through the site. So let's look at how we do that, because a big part of how we do that is by understanding what the topic is. So what is the topic of the page? And so there's all sorts of use cases with that. Site search itself is a use case for that, because if you've ever seen facets, like if you go to Amazon and you want to buy a phone and you want to see, hey, I want to filter it by price, I want to filter it by whether it's Android or iOS, I want to filter it by brand. I mean, so there's all sorts of things that you can filter by. Well, you can filter large websites by topics, and that can help people to narrow down what they're looking for. And so that's one use for it, but as I mentioned earlier, personalization is another way. So that kind of personalized content recommendation, if we know what topics people are interested in, then we can flavor what the content prediction is more to those topics. We can also help with CMS and SEO problems. So trying to understand by looking at your CMS what kind of coverage you have of topics, and understanding whether you really have enough pages about a certain topic in SEO, those are pretty hard to do. The other thing you can do is it can help with standardization of nomenclature. So you can actually have a central group that kind of names the topics, and that can help people to get a better idea of what your site's about. And so we talked about faceted search. So this is an example with one of our clients. So this is the American Society for Mechanical Engineers. So they've got all sorts of engineering content, and when they search for something like pressure vessel, there's all sorts of topics and industries that they can actually click on the left side to narrow down the information. So this is an example of how you can use that kind of content intelligence for faceting. And so you might say, well, there's a lot of topic modeling stuff out there. People who are familiar with natural language processing know that topic modeling's been around for a long time. But one of the things that we found is that what's out there now just really isn't good enough. That machines can kind of put together, here's all the content we see that looks similar to each other, but the problem is that those topics don't make sense to humans. So there's been a lot of experience using topic modeling based on clustering algorithms. And they basically provide some topics that make sense and a bunch that really aren't that great at all. And there's a whole bunch of topics that they miss. The other problem is that if you go the opposite approach, where you try to do classification, so you do a manual taxonomy, you get a library scientist to come in and have that person work through what the right taxonomy is for the topics. It takes a long time, and they kind of disagree with each other. There's all sorts of experts that say, no, that's wrong, so it takes a really long time. But the other problem is that it's really hard to classify what's in those manual taxonomies, because the system can't do a good job of discriminating one topic versus the other. And the other problem that you get sometimes is when you put together manual taxonomies, you find out what companies want their content to be about, but not necessarily what they have. I mean, we worked with one company that said, yeah, one of our big topics is sustainability. We're like, yeah, we ran the thing, and you have like 6 pages out of 30,000 that are on sustainability. And they're like, well, it's one of our big corporate initiatives. It's like, well, that's great, but you don't actually have that content yet. And so what can you do instead? Well, you can use human-in-the-loop AI for this. So first, let the machine identify the topics. So some of them will make sense, many of them won't. And then you have the subject matter experts analyze the topics. And they look at it, and they try to group topics together, combine them, eliminate ones that don't make any sense. And then you kind of run the system again, and you go around several times until now you have a system that has topics people understand, but it also is very easy to accurately classify into. And so you start with those really fine-grained clusterings that really aren't good topics for people. And you go round and round, and so you start to gradually piece together some of those microclusters into real topics. And at the end, you've really converged on a whole bunch of things. And so the reason the system can do a good job of being able to classify them accurately is because they're actually just pulling together all these different shards that they grabbed in the first place. You're just telling them which ones are smart and eliminating the ones that don't make any sense. And so it can pull these together and do it in a very accurate way. So some people might say, well, why don't we just tag the documents by hand? Every time the author goes in to update the document or create a new one, just have them pick what the right answer is. That will work. And the problem is that it's very error-prone. It's very hard for people to do that. Humans aren't good at this task because there's dozens of different topics out there, and so it's something people aren't good at. There's actually a study out there that shows that if you show the same document with the same taxonomy to the same person within a few days of each other, they will actually disagree with themselves 35% of the time. So you can imagine how often they disagree with other people. And so really coming up with ground truth is quite a difficult thing to do. And this is a task that no matter what people have done, they've never figured out how to make people better at this. So how do you do automatic tagging? Well, you first come up with the taxonomy, then you start training a machine learning model, and you begin labeling data. And what you do is you then assess that against a gold stack of data that have been labeled earlier by people, and not just by one person. You use intercoder reliability to help work through the idea that we need 3-4 people to agree with each other that this is the right answer before that becomes the ground truth. And then we start assessing. And I'll show you in a second what kind of measurements we use to do that. And so every time you assess and you see that something is wrong, then you might go back and retrain the model. You might add more labeled data, more training data, or you might actually adjust the algorithm. So the way you measure accuracy, there's several ways out there that you can do. There are some sophisticated ways, like looking at areas under different curves. There's all sorts of techniques out there. I wanted to just go through the simplest one for you. So it's called precision and recall. So these are actually things that trade off against each other. So if you think about what precision is, it says how many of the selected documents are actually true positive. So how many were correct? And recall says how many of the ones that were correct did you actually bring back? And so you can see how these things trade off against each other. You could have 100% precision if you said, hey, here's this one document and we have the right topic for it, but there could be 100 other documents out there that had that topic that you didn't correctly bring back. Now, also your recall would be 100%, it would be perfect if you just returned every document in the database and said, see, these are the ones about that topic, but you know most of them are not about the topic. And so trying to get both precision high and recall high can be very tricky. And so there's actually a way of combining precision and recall. It's something called an F measure, sometimes it's called an F1 score, and what it does is it measures the trade-off of precision and relevance. So higher scores are better, and you can weight precision and recall differently. Now, because sometimes you have different situations. Like, for example, when we talked about faceted search, recall is much more important because you'd rather add documents in so that people aren't losing the right answer. But if you were doing something like sending out email alerts, you would want to make sure that every single one you sent out was correct. And so you might want to weigh precision more. So when in doubt, you can just weigh them the same. And so we also have APIs for this content. So you can embed this stuff right in your website, and you can pull them into your CMS and put them in your page template. But you don't need to do that if you don't want to. We also have a modal that pops up on the screen that basically gives you the next best action. And so all of these things are things that are helpful to be able to do this. I hope I gave you a little bit of an understanding of how this type of system can be designed. It requires a lot of expertise in machine learning and natural language processing, and it also requires a lot of ability to pull the data together and really do that pattern analysis. But you can actually take advantage of these types of systems by pulling that data out of these APIs and using it for other purposes. So you know how difficult it is to get good visitor data out of Google Analytics. Well, there's no restrictions on pulling this data because it's a JavaScript you put on your own site. So there's all sorts of techniques you can use to understand that your SEO or your ad spending is better, and it can also be used to integrate into your other systems to give you a better customer experience. So I know we started late. I apologize for that. I will be happy to go to the room afterwards to answer questions. Thanks for sticking in with me. And I'm also happy to answer questions over email. I'm mike@solosegment.com. You can remind me you came to this a year from now, and I'll be happy to answer a question then too. So thanks a lot for your attention. Sorry again for the late start, and I look forward to chatting with you.
All right, thank you very much, Mike. What way to keep that right on time. That was amazing. I'm very impressed. So yeah, if folks have questions for Mike, definitely head into the gallery, which is the link right below his session here in Loudswarm. He'll be over there, can do some face-to-face questions. I know I saw a couple people watching the session in there, so maybe 1 or 2 people right now in there. But if you've got questions for Mike and want to get them answered face-to-face about AI and the web, definitely head into the gallery section below. Mike, I want to thank you very much for being here with us today. I'm sure if you could see everyone, they'll all be virtually applauding you as we enter this brave new world of conferences where we can't see the people we're talking to.
All right, thank you very much.